Greetings, math fans. This is our next day, and what we're going to do is we are going to do exactly what we did yesterday, okay, except now we're going to be finding theta with restrictions, okay? So there's going to be restrictions here. So finding theta with restrictions. So it's exactly what we did before. But the key here, math fans, the key, this is a key if you haven't figured that out, or somebody who doesn't feel too well either, I guess, is you need to draw a picture of the quadrants. Okay, I cannot stress this enough. It is so important. 18,000 stars around this. You have to draw pictures to see where you're at when you're doing a restriction. Okay, so my first example is going to be sine of theta is equal to negative 0.23, and I'm going to tell you, hey, cosine of theta is less than 0. So that's a restriction. So I need to draw a picture of where I'm at. Well, first of all, where is sine negative? Okay, do you guys agree sine is negative? Using all students take calculus, sine is negative here and here. Okay, that's one restriction by just looking at this value right here. And then I have my second restriction, cosine of theta is less than 0. So where's cosine less than 0? Well, it's less than 0 here and here. Okay, so where does it overlap? It overlaps right here. So your final answer will only be in this quadrant. All right, so just keep that in mind. So now we're going to do is just what we did before, is we're going to say theta is equal to the inverse sine of positive 0.23, because we need to get a reference angle. That's theta prime. So theta prime, let's bring up our calculator. So we're going to hit inverse sine of 0.23, and we'll just round to one decimal. So it's going to be 13.3 degrees. So theta prime is 13.3 degrees. All right, and then of course we're in the third quadrant. So what are you going to do? You're going to say theta is equal to 180 plus 13.3. So theta comes out to be 193.3 degrees. Okay, it's the only difference between what we did before and what we're doing now. Is now, like I said, I'm giving you additional restriction. I'm telling you, hey, cosine of theta is less than 0. Okay. All right, so let's do another one here now. These are really pretty easy. I'm going to say cosine of theta equals 0.56, and I'm going to say theta is a set of, it's basically between 180 and 360. So this is another type of restriction I can give you. Okay, not including 360, but including 180. In fact, this is just a good time to mention that 360 is never used. Okay, sometimes people give an answer, a final answer with 360 in it. It is never used. Okay, because 360 is the same thing as 0, so why would I repeat an answer? You never do that. So that's why there's a parentheses around 360. All right, so the first thing I'm going to do is I'm going to do inverse cosine to find theta prime. Inverse cosine of 0.56. So let's do that in the calculator here. Inverse cosine of 0.56, and I got 55.9. Okay, so it's equal to 55.9 degrees. Again, that's a reference angle, and let's actually sketch where we're at. So do you guys agree? First of all, cosine is positive where? Cosine is positive here and here. And then I give you another restriction, and that restriction is between 180 and 360. So let's highlight that. So here's 180, and let's do it in red. So this is 180 and 360. Okay, so where does it overlap? Where does the black and the red overlap? It overlaps only in this quadrant right here. So that means you're going to have one answer in the fourth quadrant. So here's your reference angle, and so that means theta is equal to what? 360 minus 55.9 degrees. So theta comes out to be 304.1 degrees. Okay? So restrictions are pretty easy. I got a couple more to do with you guys. Let's do cotangent of theta is equal to 1.63 and secant of theta is greater than 0. Okay, another restriction. So first thing we're going to do is we're going to do, I got to rewrite this because I don't have an inverse cotangent button, so I'm going to write tangent of theta is equal to 1 over 1.63. And then you're going to do theta prime is equal to inverse tangent of 1 over 1.63. So let's do that. Second tangent, inverse tangent of 1 divided by 1.63. Hit enter, and we get 31.5 degrees. So theta prime equals 31.5 degrees. Okay, so let's draw a nice picture here. And you're going to say, well, let's see, where's tangent positive? Or cotangent, same thing, right? So they're positive in those two quadrants. And then I have secant greater than 0. Well, remember, secant goes with cosine. And where's cosine greater than 0? Cosine greater than 0 is in the first quadrant and in the fourth quadrant. So my answer has to be where it overlaps. So that's going to just be the first quadrant. So that one's actually easy because my answer then, theta is just equal to 31.5 degrees. One answer. Okay? Sometimes it's 2, sometimes it's 1. Okay? All depends. Alright, so last example here. Secant of theta is equal to negative 1.4, and I'm telling you it's in quadrant 3. Well, that's really friendly. That's like really easy. I'm telling you the quadrant. Ugh, I'm like your best friend. Okay, so we're going to do cosine of theta is equal to negative 1 over 1.4. But of course, remember, we're going to do inverse cosine of positive 1 over 1.4 to get our reference angle. So that's going to be inverse cosine of 1 divided by 1.4. And our reference angle is 44.4 degrees. So theta prime equals 44.4 degrees. Okay, and let's draw a picture now. Cosine is, remember, go back to the original problem though, right? Because cosine, we're looking towards where it's negative. And cosine is negative in this quadrant and this quadrant. And then I'm telling you it's got to be in quadrant 3. So that's kind of a no-brainer. It's got to be in this quadrant here. So I'm going to highlight this. That's the only answer I'm going to get. And so, of course, what are you going to do? You're going to say theta is equal to 180 plus 44.4 degrees. Okay, which gives you 224.4 degrees. And that's your answer. Okay? So, anyway, that's it, math fans. That's it about finding the restrictions for this one. And like I said, it's really pretty easy. It's really the same thing as the day before, except you just have some restrictions involved here. Okay? That's it, math fans. Have an outstanding day. Adios. Goodbye.